All right, given the function h equals 2x to the 5th plus 3x to the 4th minus 15x cubed minus 13x squared plus 21x plus 18, write h of x as a product of linear factors if 2 and negative 1 are roots of the function. All right, do we have to start guessing randomly, or did they give us at least two solutions? They've given us 2. What's the degree? 5. How many more do we need to find? Okay, I heard 3 and then I heard wait.
2 more.
2 more? Why 2 more?
There's a multiplicity.
This one has a multiplicity of 2. So this is 1, 2, 3. So we have 2 more to get to the 5. Yes? You agree? All right. If they give us numbers to start with, we don't have to use the P over Q or the plus minus I chart unless needed at the end. So I'm not going to do it right away unless needed at the end. So I'm going to go straight to my synthetic. 5th, 4th, 3rd, 2nd, 1st, no power. Are they all there? Okay, so what do I write down? My coefficients are, well, let's put the box. Okay, 2, what's the next coefficient? 3, and then negative 15, negative 13, 21, and 18. Now, because they gave us that these are roots, what should our remainder be? 0. If it's not, we've done something wrong somewhere. All right, does it matter which one we pick first? Okay, pick one. Negative 1 first. All right, start dropping. All right, what's the next number? Negative 2. Negative 1 times 2 is negative 2. That gives me 1. I'm going to let you guys finish it on your own and see if you end up with 0 at the end. Did it work? Yes or no? All right, check your work. Okay, anyone know what I should do next? Okay, I heard use the same number, use negative 1 again. Why? How do I know I could use negative 1 again? Or not that I can, that I should. I have to. Now, when I do it again, do I start with the new list or this existing list here? This one right here. I don't make this top list over again, correct? All right. What's our goal? To get this down to how many? 3. Right now it's 1, 2, 3, 4, 5. I haven't reached that goal yet. Will I ever get it down to 3 if I keep using the original set? No. All right. So think of it as a funnel method. You're trying to get it down smaller and smaller. All right, you guys told me to use negative 1 again. Now, if any of you started off with 2 first, your numbers will look different initially, but in the end, we'll end up in the same place. All right, go ahead and continue on your own. What should this last number be again? 0, because we're still using our roots. Did it work? Okay. And 1, 2, 3, 4. We got it down to where we need it? No. What do we need to do? Do it one more time. Did they give us another solution? Where is it at? 2. And then we do it one more time. And I'll let you guys continue. And again, this one should also come out to be 0 because it's another root. Okay, did it work? I have 2, 3, negative 9. Yes? All right, did we finally get it down to 3? Yes? Okay, what do we do with this? I'm down to 3, what do I do? Plug it in, give me a little more. Plug in the, put in the x, x's, okay, I'm running out of room, so I'm gonna write it as 2x to what power? Plus, minus 9. How do I know it's to the second power? Because once you get it down to the to 3 numbers, it's always to the second. Or if you think of decreasing by 1, what was the original power? This would have been 4th, 3rd, 2nd. Do you see that? All right. And then what do we, it asks us to write as a product of linear factors. That means a bunch of parentheses with numbers like x minus 2 or x plus 1 and stuff like that. So what am I going to do to this one here? Factor, double bubble, 2x and x, and with the 9, either 1 and 9 or 3 and 3. Let me know when you have it. Negative 3 here and positive 3 here. And we know it has to be plus minus because it needs to be a negative 9. Let's check. Negative 3x, positive 6x. Does it give me the 3x in the middle? All right. Final answer. Write as a product of linear factors. H of x equals, the order in which you write it does not matter. I'm just going to write these first because I have them right there. 2x minus 3, x plus 3. There's 2 of them. Where are the rest?
2 and negative 1, x plus 1.
Okay, so I heard x plus 1, and this one is to the second. And why is it to the second? Multiplicity is 2, and what do I do with the last one? How do I write it? X minus 2. Definite on the test. Do you guys think you could handle that on your own now that we've done it? Yes? Yes.
How do you know when, or if you can't double bubble or review quadratic formula or what else was it?
Complete the square. Okay, yes.
And then how do you know when you do long division?
All right. His question is, when you can't factor it, you do complete the square or quadratic formula. Now that wouldn't be this problem. You only do complete the square and quadratic formula when they're asking you to find the roots. Are they asking us to find the roots or write it in factored form?
Yeah.
Factored form. If they're asking you to find the, technically we are using the roots to help us factor it, but we're not, they didn't ask us for the roots. Does that make sense?
Yeah.
So if they asked us for the roots and we got this far and we couldn't factor it, then we'd use the quadratic or complete the square. His question was, how do you know when to use the long division? You use the long division when they don't give you enough tools to use synthetic. They give you a root like this one right here. Actually, it's our next one, so let's take a look. Before I do number 6, any questions on 5? Okay, so to answer Leonard's question, let's take a look at number 6. All right. When they give you a solution like this, they give you one of the roots is negative 1 plus 2i. Now, it may not have an imaginary. It may be negative 1 plus root 2, or negative 1 minus root 5, or 5 plus root 3, whatever it might be. And it does not necessarily have to have an I. But when it's something like this, can I use, I'm going to flip over really quick. Okay, this is one of the zeros. Over here, they gave us 3 zeros. When they gave it to us like this, were we able to use synthetic? When they give it to us like this, are we able to use synthetic? No. That's when you use the long division. When you're not able to use synthetic. So what do we do with this? Do you guys remember I make x equal?
Negative 1 plus
Plus. Okay, I heard somebody say plus or minus. Is it plus or minus? It is. I'm going to pretend I forgot or that I didn't hear it, and I'm going to continue and see what happens at the end if we do forget. All right, what do I do to both sides? I add the 1. X plus 1 equals 2i. Square both sides. Remembering this side, you do have to use your double distribution. And this side, you end up with 4i squared. And when you have that foiled, let me know. X squared plus 2x plus 1. And I'm going to write that again. X squared plus 2x plus 1 equals, what is 4i squared? Negative 4. And what happens with the negative 4? What do we do? Add it. X squared plus 2x plus what? Okay. And as you guys are taking the quiz on, when was it, Monday? As I was walking around, I did have a few kids ask, what do I do here? Do I use quadratic formula to solve? What did I tell you guys about that? Is that a common mistake kids make? Yes, they do all of this, and then they're like, oh, solve because it's instinctive, it equals 0, I'm going to solve. But what happens when you do that? You end up working backwards to where you started. Now, I've said it, and I've said it, and I still had people ask me, not that that's a bad thing, I'm just trying to emphasize how important it is that you realize when you get here, you don't try to solve it because you're going to go right back to where you started. All right? So no quadratic formula, no complete the square. No complete the square, no quadratic formula. But we are going to do what? Long division. All right, so make some kind of note, like Leonard asked, how do you know? Make some notes to yourself. When they give you a root or a 0 that you cannot use synthetic on, it's going to be a long division problem. All right, what goes on the inside? 4x cubed minus 5x squared minus 6x minus 65. And what goes on the outside? X squared plus. Now, what should be the remainder on this one? Why? Because this is a factor. And how do I know it's a factor? Because it came from one of the zeros. I used the 0 to get it. All right, let's go ahead and work it out. X squared times what is 4x cubed? 4x, and that gives me what? 4x cubed plus 8x squared plus 20x. And what do we do to all of our signs? What does that change them? Negative, negative, negative. Cross out. What do I get here? Negative 13x squared. Keep going. Minus 26x, and then minus 65. All right. Starting over. I'm going to cover and cover. X squared times what is negative 13x squared? And then you distribute. Negative 13 times 2 is negative what? 26. And then negative 13 times 5 is negative. And then what do we do with all of our signs? That becomes minus, and these two become positive. Oh, thank you. Yeah, that wouldn't work otherwise. And I'm hoping you did it on your own. Negative 13 times x squared. You guys said negative 13x squared, but I didn't write it. So when I change the sign, it becomes positive. And it does need to become positive because what has to happen with these two? They have to cross out. And do they all cross out? Like we said they would, because the remainder should be 0. Now, on the answer column for the test, when you have something like this and say it was number 6 and you have your answer column, should you write 4x minus 13 as your answer? No, it says find all the zeros. 4x minus 13 equals to 0 gives me what as a 0? 13 over 4, comma, what's my other solution? Good. So again, I'm going to pretend that I forgot. Would I get this wrong? Yes. A few reasons. Well, anybody tell me how you knew it was plus or minus? Like what triggered it? Conjugate. Conjugate root theorem. Anyone else? There's 3 roots. There's 3 solutions here, and this one only has 2. Should you know there's a plus or minus? Conjugate root theorem. If they give you negative 1 plus 2i, its conjugate is also a solution, negative 1 minus 2i. Got it? Now, those of you that said it from the get-go, some of you said over here, negative 1 plus or minus 2i. If I had put it originally, would I still end up with the same work? What happens right here when you square a plus or minus? Does it still become positive 4? I squared, which then becomes negative 4. So if you did forget it in the beginning, you'd be okay, but if you forgot it all the way at the end, would you still be okay? No. So remember plus or minus, the conjugate root theorem. Questions on that one? Leonard, does that answer your question that you asked earlier?
Yeah.
Okay. Any others before we move on? Okay. Find all roots. Did they give us any roots to start with? No, they gave us an upper bound or lower bound? They gave us a lower bound, but did they give us like 2 as a root, start with this? Or negative 1 plus 2i as a root, start with that? No. This is the one where we're starting from scratch and we have to do everything. Do you guys remember what they were? P over Q. And what was the other thing? Plus, minus, I chart. All right, so we're going to do our P over Q and plus, minus, I chart. So you have to remember that. When they give you nothing but maybe an upper or lower bound, you're making guesses. And that's when you do your P over Q, your plus, minus, I, and you start making guesses. I'm going to do the P over Q, plus, minus. The factors here are 1. That's really nice. So all I have to worry about are the factors of 28. Do you agree? Because all of them over 1 will stay the same. So don't forget the 1. Does 2 go into 28? Does 3? Does 4? 5? 6? 7? And what would the next one be? 14 and 28. Okay. Now, negative 7 is a lower bound. If it helps you, write a positive list and a negative list. And I say this because when some of you were taking that quiz, and I think it gave you 2 was an upper bound, or 1 was something was an upper bound, and you guys crossed out everything, including the negatives. Don't forget, just because 2 is an upper bound or negative 7 is a lower bound, the opposite sign still works. Okay, so here's what I'm saying. If it helps you, make 2 different lists. You don't have to, but if it helps you, I suggest you do it. Positive 1, positive 2, positive 4, 7, 14, 28, and then the opposites of all of those. And then which ones can I cross out if negative 7 is a lower bound? Negative 7, negative, and negative 28. All right, so I'm left with guessing 1, 2, 4, 7, 14, 28, and negative 1, negative 2, negative 4. Yes?
What is lower bound?
There's no number smaller than that would work. So she asked, what is a lower bound? So there's no number smaller than negative 7 that will work. If it said an upper bound, there's no number bigger than that number that would work. Okay? P over Q, plus, minus, I. I'll do that over here, plus, minus. Actually, before I do it, I'm going to do the f of negative x underneath it, or since I have room on top, I'm going to do it at the top. All right, positive or negative x to the 4th when I plug in negative x. Positive, plus 11x cubed or minus? Minus, plus or minus 40x squared? Plus or minus 58x? Minus, plus or minus 28. Okay. All right. F of positive x is where I look at the number of sign changes going across here. How many sign changes do I have? 0. And then minus. I'm not looking from up and down, I'm looking just straight across, this way. How many sign changes? Are there 4? So I put 4 comma 2. And then what is the degree of the original problem? 4. So 0, 4, how many imaginary? 0. And then, yes.
Why'd you cross out -7 if it's included?
-7's a lower bound. It wouldn't work.
Oh, okay.
Okay.
So upper bounds or lower bounds?
You don't have to test those, no. All right.
Can't you subtract 2 from 2 and put 0 straight?
The negative, okay, yes, I was going to get there. Thank you. All right, so I'm going to cover the 4. What's the other possibility? 0, 2, and then what? 2. Remembering that I should always be even. 0, 2, 4, 6, and so forth. All right, these numbers, how do we get them? Whatever we start with, and we subtract by what? 2 until we get to either 0 or 1. In this case, you don't just add or subtract, you have to look at all your combinations. All right, this is nice. Why is this a nice tool that we have in this case? There's no positives. Can I cross out a whole other chunk of my numbers? That whole list right there is gone. Did that make it even smaller? Yes.
How come on the negative it's not 4, 2, 0?
4, 2, and 0. Thank you very much. Good catch on that one. I heard a few of you say, yeah. Did you do that on your own, get the 0? What does that mean with my imaginary? Okay, so 0, 0, 4. All right, start making some guesses. Should you be guessing any positive numbers? No. Let us know when you have one that works or doesn't work. Negative what? Negative 1. All right, you guys are way ahead of me. So give me your coefficients that you have. 1, 11. Okay, can you guys give me your numbers? You have 1, and this is negative 1, 10, negative 10. Keep going. All right, we have 1. Now try another one, but when you try another, should you go from the original list or your new list? The new, because what is our goal? To get this list down to what? 3. And is that ever going to happen if we keep using our original list? No. Okay, so go for it. And let us know again if you have one that works or doesn't work. Negative 2 does work. All right, so give me your numbers. You have negative 2, 8, keep going, negative, and then negative 28, 0. Are we down to 3? All right, so then I have 1x squared plus 8x plus 14 equals 0. And the first goal is try to factor and solve. Does it factor? Okay, so this was the question that Leonard asked earlier. When do you use this? When do you use that? Are they asking us for the roots in this one? Yeah. They're asking us for the roots, and I cannot factor. What do? Quadratic or complete the square, your choice. I'm going to let you guys do it. What method are you guys want to use? Complete. I heard both. All right, so go for it, and you guys decide. Does anybody need a reminder of the quadratic?
Yeah.
Did they ask on the test to do either quadratic or it doesn't matter?
It doesn't matter. On this one, if I were, there's some problems where I don't like using complete the square because the middle term is odd, but this one, the middle term is even, so I would use it if I prefer that method over quadratic personally, but it's your choice. right, anybody have it? -4 plus or minus still root 2. Anyone else get that? -4 plus or minus root 2. Okay, I'm going to show you my work. I did complete the square only because I said earlier that's my preference, but you could have used quadratic. If you complete the square, you minus the 14. You can't see it because it blended in, but you put blanks on each side. Blank there and blank there. And how do you figure out the blanks? You take the middle number and do what? Half it and then square it. Half of 8 is 4. 4 squared is 16 in both blanks. Double bubble, it's quantity squared. -14 plus 16 is 2. Square root both sides, plus or minus. Subtract the 4 and you're done. Did anybody use quadratic and get the same? Yes? All right. It asked us for all the roots. So again, if this was a test question, what would you put on your answer column? Did I heard somebody say -1? -2? -4 plus or minus root 2. How many solutions or roots should I have? 4. Did I end up with 4 here? 1, 2, 3, 4? Yes? Did I hear someone asking a question? Yes.
Why wouldn't you use the normal -4 without the plus or minus as well?
The normal -4.
That's in the part of the P over Q, the negative part. Yeah.
Okay, what about it?
Why wouldn't we add that as well?
The -4?
Yeah.
Because nobody tried -4 in the boxes. When we're saying it works, it works. No one ever said that one did work, so I'm assuming it does not. And we can try it really quick.
No, that's fine.
Okay, it doesn't work. All right. Okay, are we good? Number 8, given the again, test question, so make sure you've digested, you've got it. Given the polynomial f of x equals blah, 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 find all possible rational roots. What does that mean? Find all possible rational roots. What are they asking us for here? P over Q. That's the only reason why I wanted to go over this one, is so that you remember what they're asking for. When it says list all possible rational roots, P over Q. What are the factors of 4? 1, 2, and 4. What are the factors of 8? 1, 2, 4, and 8. Plus or minus, parentheses, factors of your last number over factors of your first number. So I'm just going to list the first ones. 1, 2, 4, and 8, because all of those are over 1. Do you agree? And then all of those over what? 2. 1 over 1, I'm sorry, 1 over 2 is 1/2. 2 over 2 is, I already have it, you can write it again. 8 over 2 is 4, I already have it, but you can write it again, comma. Okay, so I've done the 1, 2, 4, 8 all over 1, all over 2. Now I'm left to do it over what? 4. Okay, so I have 1 over 4. What is that?
You skipped 4.
Did I skip 4? Never mind.
Oh, yeah, now you got it.
Okay. 1 over 4, and then what? 2 over 4. Why is that it? 2 over 4 is what? Okay, 4 over 4. 8 over 4. Is that all of them? All right. Questions? We're good? Okay, find the degree of this polynomial. I'm going to have you guys do that really quick. What do you guys have? Louder. 10. Did I hear a 7, an 8, 9? Are you guys not sure? Okay, I want to go over this one because most kids, if I cover this, most kids can say that's 5 and 3 and that's 8. Yes or no? What's different about that last one? It's the squared is on the inside. Is this factorable? It doesn't matter if it's factorable or not. It might be, it might not be. But if this squared is in here, does that count as a degree? It does. Because let's pretend we could factor it. If I did double bubble, would that count as 2? 1, 2, and then 3 and the 5? Yes or no? All right, but even if it didn't factor, would it count as 2? It does. Does that make sense? So you do count that even, and I know someone asked me that early in the week. They said, oh, I didn't know that. So I'm hoping you got it. If the x squared's on the inside, it still counts. So 5 plus 3 plus 2 is what? 10? All right, last one. Are we ready? Which is the possible graph? We're going to do some process of elimination. What is the degree? 4. And it's positive or negative? So which ones can we cross out? Or which one? A. Can we cross out A? Why? Because it's low, low instead of high, high? All right. Anyone have other suggestions on how I can do more narrowing down? The y-intercepts. Okay, what's the y-intercept? -7. All right, which one can I cross out? D. Okay, do you guys see how they use the -7? I mean, there's no numbers there, so we don't know which one is -7. Do you see that? All right, there's one last thing we can use. Anybody know? Good job. The plus minus I chart. How many positive, how many negatives? Imaginaries may not really count on this one, but how many positives, how many negatives? The positive chart might be enough. Let's check. How many sign changes are there here? 1. So the one with only one, I don't even need to do the negatives. How many of these only have one positive? B. So what is the answer? B. Got it? Make sense?
Wait, could you explain that again?
The number of sign changes here, there's no, none, none. Right here, there's only 1. I'm going to go ahead and do the negative one really quick. They would be positive 5x to the 4th minus 4x cubed plus 2x squared minus 7. How many sign changes do we have here? 3. So it's 3 comma 1. All right. We know for sure we only have 1 positive and either 3 or 1 negative. Then there's no way that this one can work because this one has 3 positive solutions. Do you see that? And there's no way there's 3 positive solutions. This one has 1 negative, and that's a possibility, but we have to cross it out because of the positive solutions. Where this one has 1 positive and 1, 2, 3 negative. Does that make sense? All right. Questions?